Hello everyone, welcome back to the third channel in our video. Today we will be learning everything there is to cover about the numerical operations which Python's inbuilt NumPy covers. So what is NumPy? NumPy is the fundamental package for scientific computing in Python. It provides a powerful n-dimensional array object, sophisticated broadcasting functions, tools for integrating C and C++. It is also useful for linear algebra, Fourier transform, and random number capabilities. Why to use NumPy instead of Python list? Speed. NumPy is almost 50 times more faster than Python list for numerical operations. It is more memory efficient, means it stores data in a much smaller space more compactly. It is much more convenient. There are already many built-in functions in NumPy, rich mathematical functions, which makes our work much more easier. It is also the foundation of more complex things in machine learning like pandas, sklearn or scikit-learn, TensorFlow, PyTorch, etc. Point to be noted is that a more advanced version of NumPy is SciPy, which is used for more complex arithmetic operations like linear algebra and technical computing. Although for now you don't need to worry so much about SciPy. So yeah, we will only focus on NumPy for now. So let's understand how we can implement every single thing that NumPy has to offer. First of all, we will see how we can install NumPy. Very simple. We'll just do pip install NumPy. As it is already installed in my system, it will show requirement already satisfied. Otherwise, it will just take a few seconds to install in your system. How we will import it? We will just do import NumPy as np. This will import it. So the first thing that we are going to cover is how can we create arrays, right? Create arrays. So let's understand. Very easy. We will just do a equals to np dot array, right? We do this 2 comma 3 comma 4. That's it. That's your array. You can print it. You'll see. Yeah. So that's how you make a list or a one-dimensional array. Now here we will understand a few interesting things. Like first of all, if you want to do an array of like zeros, you will do something like np dot zeros. You will just give the row and column, right? Cannot intersect three areas. What is that? A just probably like this should work. Yeah, yeah. See, so now we have a 3 rows and 4 columns made of only zeros. Interesting, right? Let's do ones. Three. We'll also print one work. Yeah. Now you see zero and ones. Let's see how we will fill the whole matrix with a single number, right? Okay, so now let's understand how we will fill a whole matrix with a single number. So how can we do this? With this np dot full, we want to mention the rows and columns and what do we want to fill it, right? Yeah. So let's print this too in the same place, right? So we have understand how we will do zeros, a full matrix full of zeros, a full matrix full of ones, and a full matrix full of any number, any chosen number of use. Next. Okay, so let's understand what a sequence is. Let me give you an example first. So suppose I do it like this, right? np dot a range, np dot a range. We put starting, we put the ending, we go. what did happen here? Sequence is basically the a range function. It goes something like this. We put the start, the end, the step. Now what does this mean? In the code we put the first starting point of our list, which is 0. We put the ending point, which is 10, and we put how many steps it will go, like 0, so we have given 2, right? So it will be 0, 2, 4, 6, 8. These 5 will come. The 10 will not come because 10 is the maximum limit, and the maximum limit does not comes when we are trying to put the a range function. So yeah, another one is the linspace, right? Let's do np underscore linspace. Almost similar. Let's do 0, 1, 5, right? Doing this, see what happens. So what did we see here? Between 0 and 1, we got 5 values which are equally distributed between each of them. Like you will see, there is a difference of 0.25 between each values here. This is what linspace means, right? So these are the few examples. We can also do something like this in p dot random, but random we can do 2 comma 3. And this, what it will do is it will give a random values of normal distribution which follows the normal distribution curve, right? You can also do this for integer values. mm, and int, right? Can do 0 to 50 comma 2 comma 3, something like that. Yeah, we'll also get between 0 and 50 2 cross 3 matrix, random value, random integer values between 0 and 50, which is following the 2 cross 3 matrix. So that's it for the arrays. Next we will move on to something proper. Okay, so first of all, let's build an array. Name would be array 2D, as we will be making an 2D array. So let's do this. First one, let's put 1, 2, 3. The next 3, 4, 5, 6. Print this once also, so that we get a yeah, understanding of, yeah. So we have just got it on 2D array. So okay, so first we have just printed the 2D array. So how will you get the shape of the array? How will you understand what is the shape of the array? Very simple. 2D, sorry, 2D. Okay, 2D. So it's a 2 cross 3 matrix. This is the shape. You can also get the dimensions. Yeah, array underscore 2D dot endings. This will give you a snow, sorry, it will be endim most probably. Yeah, the dimension is 2. You can also get the size of the array. I think also get the size, it already is coming, but let's do it by ourselves. Dot shape. Print the shape. Yeah, the shape and size is almost equal. We can also print the data type. What is the data type of what is the data type basically of the array that we are trying to solve, right? Yeah, should print the data type. Yeah. So the data type is obviously integer 64. There are also a few other things that we can do, like how much bytes it's consuming. We can also do that. There are also one more thing that we can do. Yeah, we can check how many bytes it's probably consuming. Bytes. Hmm, was it actually in bytes? Probably. Yeah, in bytes. 48 bytes. So that's it for the array properties and inspection. We'll move on to indexing and slicing. What is indexing and slicing? We will go up here. So first, let me write it for you. First, let me write it for you. Indexing and slicing. Okay, so first we will be making a 3D array. For this example, we will be making a 3D array in p dot array 1, 2, 3, 4, right? 5, 6, 7, 8. Last one would be 9, 10, 12, right? So let's print it to see what we are getting here, right? So we have got our 3D array. So how will you access a single element from this array? It's very cool actually. So you will just to print, you will give your array 3D and you will mention what you want to take out, the row and the column. This is the row. Suppose, how will I say? Let me just show you first, right? Row 1, column 2. Which number do you think will come out? Let's see. Yeah, so it come out 7. Why? Because it comes from row 0, row 1 and row 2. So we have print for row 1. So this will be row 1. This will be row 1, right? Next, we have print for column 2. Column 0, column 1, column 2, right? So in column 2, row 1, this is the element that is going to be printed. Next, let's understand what is slicing. Right? This was just basic indexing. Let me just write it here. This is just basic indexing to find a single element. So what is slicing? Let's understand. Let's understand what is slicing. Slicing is also kind of like it happens like this: start and stop, right? So let me give you a few examples so that you can understand. Print array underscore 3D, and then you will give 0, comma 1. So what do you think this will print? Let's check it out. It will print 1. Okay. Oh, okay. Sorry. There will be no 1. Let's print this one. This printed what? This printed the first row because we have just mentioned the first row here, right? We have just mentioned the first row. So it's printed the first row. Let's do something else too. And let's put 3D. Let's do second column. 2, 6, 10. Easy enough for you to understand. We have just mentioned the second column here, which is 1 because column starts from 0. We can also do something like this. array 3D into this. You see what we have done here? We've printed for what? 7, 8, 11, 12. Now you say me in the comment section, this is your homework. Why does this output come from this slicing? Let me know. Next, and we can also do a little bit of Boolean indexing. This will be very much needed when we will be doing the ML operations, basically. So let me just write it, useful for ML operations. All right. So how I will do it? Come on. Let's just say, suppose, yeah, mask equals to array 5. So what we are asking for, okay, my name is not array, it is array 3D. So what we are asking for, we are asking for all the elements in my array which are bigger than 5. These can also be printed. How? Array underscore 3D, okay, like this. Yeah. These will just flatten out and print all the elements that are bigger than 5 in our array. That's it for indexing and slicing. Next, let's move on to a few mathematical operations that we can do in NumPy. Okay, so yeah, we're moving on to mathematical operations that NumPy supports. Very easy, and it will be very much useful for you. So first, let's make us two arrays. np.array, comma 2, comma 3, comma 4. Also make a second array, np.array. What will I do? Let's do 5, 6, 7, 7, 8. These are the two arrays that are given to us. So let's perform all the operations that NumPy supports. First is print. Let's do add normal a plus b. So yeah, you will see that it is doing element-wise addition in each and every column and printing it. We can also do subtraction a minus b. So simple, right? Yeah, yeah. Obviously, it will come like that. We can also do multiplication a into b, sorry. And we can also do normal division to a by b. Yeah, simple, really. Very good. What else we can do? We can do a very important thing here, which we are going to understand, which is broadcasting, right? Let's understand broadcasting. What is broadcasting? Suppose we do this, a plus 10. What do you think will be printed? Any suggestions? Will the element 10 will be added to the first array and it will be 1, comma 2, comma 3, comma 4, comma 10? Will the element be added? Or will this number be added to every element? What do you think? Let's see. Right. So the number got added to each and every element in the uh, array A or array 1. Let's print this 2, right? Yeah. Simple, really. This is how broadcasting, a little bit about how broadcasting works. Let's do a few matrix operations too. What matrix operation can we perform here? Yeah, matrix A equals to np dot array. We're basically making two matrices, right? Okay. comma 2, comma 3, comma 4, matrix B equals to np dot array 5, comma 6, comma 7, 8. Right. So we have made both of our arrays. Now we can do matrix multiplication. How? Very easy. Show you matrix multiplication. We can do something like this. Matrix E, where is the at the rate? At the rate matrix, what happened? Matrix B, right? Yeah. Print it. Yeah. So easy. So easy, right? Matrix multiplication. And we can also do normal element wise multiply. Let's see that too. I don't know why it is showing suggestions in every step. It's kind of annoying sometimes. Sometimes it's good. Sometimes annoying too. Matrix A into matrix B. Yeah, element wise multiplication. What else can we do? We can do a few more special functions are available in the mathematical operations. Let's see them. Right. Yeah. Some useful functions. First is we can print mean. We can print mean. How we will do it? Np dot mean of A. Right. So it will print the mean value of A, which is 2.5. We can also sum the values, sum the elements actually. Np dot sum A. Yeah. What else can we do? We can print standard deviation. Now these are statistical terms. We will be needing it when we will be doing machine learning. So that's why I'm showing this to all of you. Np dot sda should work. Yeah. What else? What else? What else? What else? What else? We can print the max too. Right. Oh, the np dot max. Say, let's print this. Yeah, so the maximum value also get printed. You can do the min right like that. Yeah, not wasting more time. Yeah, so these are also the few useful functions that we can do in NumPy in mathematical operations. Next let us move on to reshaping and aggregation of functions which NumPy also provides for us. So let's move on. Okay, let's move on to reshaping and aggregation. Right. So let's do something. Give any name. See what this prints. Yeah. So a 1D array of random 12 numbers from 0 to not random 12 numbers, 0 to 11, 12 numbers of a list is printed here. Let us reshape this. How? Let's make it kind of interesting too. Let's make this 3, 4 and print the matrix. Cannot reshape array of size 1 into shape 4. Okay. Okay. Oh, got it. Array underscore shape. Yeah. See, it got printed into 3 rows and 4 columns. We just reshaped a 1D array into a 3D array. How cool is that, right? We can also flatten it. Let's see how we can flatten the array. Flatten equals to array underscore reshape. Flatten. Yeah, that's probably it. Print flatten. Again got printed into a 1D array. Right. What else can we do? We can transpose. Um, yeah, can transpose the matrix. How? Transpose equals to array underscore reshape dot t, right? And we can print it transpose. Yeah, you are not really getting an understanding of what is happening here. Let's do something. Let's first reshape it to 3 comma 4 again, then do it. Should work now. Yeah, you will see that the rows changed into column here, which is how transposing works. Next, let's move on to aggregation. Let's do print uh, matrix.sum, kind of like that. That's what we want to do. Yeah, let's do that. Sum of each column, right? So this np.sum matrix this equals to 0. Let's see what happens. Sum of each column 12, 15, 18, 21, right? Sum of each column 4 plus 8, 12. This is 15, this is 18, this is 21. This is how we will do. Now, if I do something like this will be for rows, and this will be for rows. No, let's take it back. Yeah. Sum of each column is this. Let's print the mean. This time for each row, mean for each row, right? So what we'll do is same np dot mean underscore matrix. Okay, comma access equals to 1. Spend this to, yeah. So we have got the mean of each row, which is 1.5, 5.5, and 9.5. The last thing here is how to concatenate. How we will do it. We already have 2 arrays back, right? A and B, matrix A and matrix B, right? And we have A and B. So how we will do it? Very simple. We combine both of them based on np dot concatenate. What we do is we will first put the 2 arrays that we want to concatenate, and we print combine. Yeah, they got concatenated. That's it. Now we will move on to the much more complex things. Which are practical ML examples. So let's go. You practical ML examples. Right. First, let's understand how we will do data normalization. What is normalization? Let me know. So first, let's make an array, one-dimensional array, 100, comma 200, comma 300, 400, 500, right? So let's understand how we will do it. Normalize. What is the formula of normalization? Mean minus standard deviation, right? Data minus mean by np dot std data and normalize. Yeah, this is how the normalized data. This is how we will do data normalization using NumPy. We can also do encoding. Let's understand one hot encoding. Don't worry, these are new terms for you, I'm sure, but we will understand each and everything once we get into actual ML tasks. For now, just understand how NumPy works here. Let's do something labels. Let's make another array. This time a small one, 2, 3, 4, right? So one thought variable name np.eye, we do 3 labels, right? Then we just print one. Index 3 is out of bound for access 0 with size 3. What's now? What else can we do here? We can also do a little bit of batch processing. To understand how that works. First, we will give a batch size. We will give how many features we want. We'll give x equals to np dot random dot 10. We will give the batch size here, comma the features. We will mention the weights, which will be np dot random dot 10 for now. And we'll give the features, comma 1. We'll give the predictions equals to x at weights, and next we will just we'll just print the predictions. These are the prediction of the 10 features. These are the predictions, the batch processing. Now, what are this? We will get into details later, but for now, understand these other things that we can do in NumPy. Yeah, so that's it. These are all the things that almost everything that NumPy can do. There are obviously much more operations. You can check it on the NumPy platform. Actually, it's just NumPy documentation. You can check the NumPy documentation. There are a lot of things that you will find here. But yeah, for now, these are all the things that NumPy basically does, the fundamentals. I will attach this notebook under this video. Feel free to check it out. Do subscribe to my channel, like this video, share. Thank you.